And I will put a data dictionary here to say, what is trust one? What was this question? Trust was this question. Does that make sense now? It's one. So that's exactly what I want you to get used to it. Whatever you do, whether it's a machine learning or survey-based, mostly for survey-based, this is what you have to have. A data dictionary where you coded your columns names with how you measure cost. One is written down. So this is how we measure it down for demographics with 12 variables. Age and from years, this is how I measured it. Instead, those are the questions. Gender, I put 1 for male, 0 for female. Does that make sense now? Indication, I used it ordinal, highest 4 years, 4 years, and so massive the total. So I used it as personal experience from the years for time, 1, 0. And see the data outputs, right? So we can be getting all those other ones. But for now, this is how this data also has been imputed. What we mean by imputed means whatever was missing values, we replace them with the average of the column. So substitution, imputation, they call it, right? Imputation means basically substitution. So you have an option to delete the row, but in this case, I use the imputation, which replaces it with the average. So this data is ready for analysis. So now what we need is open WarpPLS, and then we can just WarpPLS is then it gives you direction of step by step. So for me, I will place it one, I will click on one, and I will click on create project time. Create project. And then I will save it somewhere where I can find it later when I come up. I know my programs are getting. I will call it and now, step 2 is activated. Well, it's going to keep on stepping. But now I need to be from file. So in other words, I want to upload that Excel file just down. So just download it. And I want to read it from there. I will go find my file. So I don't see it here, although my Excel file is already there. But the reason is because the file type is by default in txt. For me, I will click that one and select all files. So when I select all files, I'll be able to find Excel file. Right? So I'll select the Excel file and say OK. And I'll say OK. Now I will read the output. Meanwhile, I want paper. This is actually the paper that we want to read. Paper one, all this actually interpretation for so 28 So what we did in this study, we implemented the study by one of the major researchers of IS came up with this model. So for us, we replicated it using other technology. In this case was a personal cloud, like Dropbox, right, and so on. And this is the model that we are going to replicate with this and that actually. Going back to WarpPLS, if we have the bank and create raw data, yes, that's what we want. We want the raw data. Keep it at the next page. I will not touch anything. I'll just say, okay, next. And okay. They can say, yes, it looks good. Enjoy the columns here. They have titles. And I would say, yes, everything looks good. I would say, okay. So I will not do anything different. Just yes, yes, right. Then proceed to step three, pre-processing. So pre-processed data, what it does here, it does the imputation for us. It looks for columns that have a lot of missing values. If it has more than 20% missing values, it will drop that column from your analysis. Otherwise, you automatically will. Right? So it does all of that cleaning for you. So now everything looks good. It will say, okay. Say, okay. And then it does this data look correct. See, it's always verified with you. Feedback. Yes, looks good. So now this is the step where we are going to create one. So what I will do is I like to create like two. That's why I created my model here, kind of two screens. So this is what I will. So this is the canvas that I'm going to use to build this guy. So now let's go to create a variable options and create variable. So whoever is following me, everyone is good. Who is following along? Okay, you're following along. Okay, so I will go to create a variable, and then I will click somewhere inside. So the first one is trust. So I will add 1, 2, 3, 4. I add it here, and then I will name my basic variable here trust. Up to you what you want to name it, but just keep it short, like simple and short, right? As long as you know how to. And then I would say, create that. Now I created trust. Where should I put it? I'll just mimic this guy. I'll just put it in the same spot of this guy. Now next, again, create the variable. Then familiarity is the next one. I will say add 1, 2. Then I will call it count. Familiarity. Familiarity is 1, right here. And I will create next one, which is recipe 1, 2, 3, 4. If you want to know how I measure each one of those, you can go to the dictionary on list. Then I will put it by attention. So attention here, attention here. That open note for trust. Algo. Actually, he is the $150 paper. When he did the application, he is the $150 paper submitted. So he loved it because confirmed it's fine with that. I think right now, price. So now I have all the variables, right? Double check. So now they didn't add any control variables. I have control variables, but we didn't have. So we'll just make that there without control variables. Does that make sense? So now let's connect links. Red links functions create red link. And now we'll do satisfaction and trust. So I click on the satisfaction and then I click on trust. It will create that. And that works pretty much. That's fun. It's fun. Yeah, perfect. So now what I'm going to do is I will just connect all of the ones that I have here, all connected. So satisfaction and risk. So start from the left. And on the RND, let's see. That the RND process. And we pass or no? We pass. It's fine. I think that this is better. That way you can know you have to make a mistake. Then yeah. Frankly, if they get anything, they everything does everything look good so far? Did I miss anything? Good, right? So now when we are done building the model, so basically this is all you need. Build the model, get good at the data, save, model, and close. So I save the model and close. Then I'll go back to my model. So now it's building. So before I run it, this software has multiple algorithms. So we need to go to settings here. And then go to view change, general settings. So it uses PLS regression and it chooses here WarpPLS. WarpPLS, that means it is nonlinear, right? Nonlinear. So for me, I want to choose this one and change it. Right? So I'll save it. And now I can process the file, this one, and then say perform. Now let's see the clerk my results. It's similar. Yeah. Now with the idea. So now this is how I want you to practice. I remember the first time I did the replication like this, that was the best learning moment for me. When you know and you can replicate the study, that means this is now you can do it by yourself, you can do it for your own study, you can do it for other people's studies, you are done. All right. So now we have the R squared, we have the beta coefficients, we can report. Okay. So now we have this model. Again, now let's go back to what we just covered earlier. The measurement model, the structural model. Before I judge that, I say, oh, this is a beautiful model, everything looks good. Right? Before I do that, I have to check the measurement model. So the measurement model, I need to see my loading and cross loadings. So I will go to view, indicator loadings and cross loadings, combined loadings and cross loadings, and for thrust. I will see for thrust, the loadings, they look good. And then for familiarity, they look good. Risk, they look good, about 0.5, so all of them, they look good. All right, so now I will scroll. Everything looks good. Now I don't have any issues with conversion value. Now I will go to latent variable coefficients. Do I have any issues with the reliability? So composite reliability. They are all good, about 0.7. It's great. Combo alpha looks great. They are all about 0.7, which is great. VIF. So VIF here, they are all less than 5, which is great, looks good. Now remember the normal versus not normal. So here, I will go with these stringent ones here at the bottom. The one is the 2 and 3 from the bottom. So there is at least 2 variables that are constructs that are not normally distributed. So I want to see the histogram. See, this one is skewed, right? So it's not normally distributed. The ones that they are distributed or normally distributed, like this one, it's kind of considered because of this guy. But you got the idea. Now, can I justify the use of PLS because of not meeting the assumptions of normal distribution? Yes. I have at least 2 variables here that are not normally distributed. So I can justify the use of PLS, right? So now we have done latent variables. Now the discriminant value, I will go to the correlations among latent variables and error. First option, AVE. So I look at the ABE, which is in brackets, and the correlation of the constant trust with the other variables. Are they less than the ABE score? Yes, that is very good. Same thing here for familiarity. Is it greater than the correlation of familiarity with other variables? Yes, it is larger, so we're good. This guy, the same thing, the before and after. So all of them, they are great terms of discriminant validity. So now I am good. I am ready to move on to basically for the measurement model. So the measurement model, I see everything looks significant, everything looks good in terms of values. The R squared are great. So I have 44. So remember what is the 44? Is that weak, medium, or strong in terms of R squared? Medium. Medium. Yes, medium. It should be above 50, right? To be strong. So, but still good, right? 44% in intention to use. Great. So now I have everything is significant and supported except for this guy. Perceived is huge. When I'm controlling for other variables, it becomes non-significant, right? All right. So now we said we are going to look at the p-values. And what is recommended by those two papers we read today? You should always look at the effect size and the confidence interval, right? So for the confidence interval, let's look at the effect size first. So to see the effect size, there is actually under view and here indirect and total effects table. So this is what we have. It tells you the indirect effects for all paths. So for me, what I will do is I will go to the all paths. I will scroll down all the way. And then I will go to the total. I will go to the total effects. So now the total effects, I have the coefficient total effects. And I have the p-values of the total effects. And I have also the effect size for total effects. So this is what I am looking at. This is what I need to look at. The effect size for total effects. So trust, that is 4.5%. Is that good? Is it bad, weak, or moderate, or strong, or really bad? We should not even consider it. Moderate. Yes, perfect. It is. No, it is small.
It is small,
but it is reasonable, right? It is weak, but it is reasonable. It is greater than 0.02. Perfect. So now those guys are still. This guy is medium. Medium, right? Medium. I think it goes to 35, right? Perfect. So now we can see that this one is horrible. This one, the familiarity with risk, right? Yeah, that's less than even 1%. Right. So yes. So let's look at the familiarity and risk. Was it significant here? Familiarity and risk. You see now it shows significant is 0.17. And the p-value is less than 0.01. So now do we see now? P-value might be deceptive sometimes. So in this case, it is deceptive. It shows it is significant, but the effect size, the practical and the relevance is almost nothing. Right? All right. So now we got this idea. So now let's look at the confidence interval and how we can find it for under explore, and then it should be under explore T ratios and confidence intervals. So I will go to the confidence intervals here, and I will see for risk. So again, the confidence interval, they have to be both negatives. Or in other words, we don't want it to include zero. If it includes zero, that means it's not significant. Does that make sense now? The confidence interval, we have the lower and the upper. right? The lower and upper, they have to be both negative or both positive, and they should not include the zero. If they include the zero, that means it's not. Everyone is good so far? All right, so now can you spot anything that is not significant based on the confidence interval, based on those results? I see this one. You will see the perceived ease of use and intention. So intent and oh yes, you're right. So intent that trust is not. Yes, it includes the zero. It's not significant, It's not, you know what I mean? It's not significant, right? Yeah, the zero, because if you go from negative 0.003 to 2, yeah, that means the zero is between those, right? So that means this guy, because it was also weak, like even the p-value, I mean the beta coefficient, and the p-value was 0.03. It was pretty weak, so here the confidence interval is telling us that's not right. And we should be wary about it because again, that was the problem in the papers that you read. They did MISQ at the top journals and they found that a lot of people don't report the confidence interval, they just report the p-values. The p-values are, they have issues as we saw right now, right? So perceived ease of use and intent also. Perceived ease of use and intent also it confirms it. So this was not significant. So everyone is clear now what we have and how we can find those guys to report them in your papers, right? So exactly this is how you are going to report. You're going to create this one like what you created in PowerPoint for your initial proposal. When we did the first stages of your paper, those tables you created them by yourself, so they are not going to be created. Right? You create the table and you enter those. That's how I personally do it in person, right? So everyone is clear and good about this? All right. So I will stop here. And